Welcome students. I welcome you all in this lecture of Engineering Graphics and Design. I am Yogesh Panchal and today I will discuss on chapter number 4, projection of points and lines. Now in this chapter our first topic is projection of point. So we are starting our orthographic projection journey. Actually, we want to take the projections of point, line, planes, solid, and any 3D object in this subject. So we are starting here of projection of point. Okay. So as you know, the projection, there are three types of projections: orthographic projections, oblique projections, and perspective projections. But in these subjects, we are concentrate on only orthographic projections. So orthographic projections means any object is projected on the principal planes. Okay. We have three principal planes: horizontal plane, vertical plane, and profile. So when the object is projected on vertical plane, when you're looking from front, that projection is known as front view. When we observe from top, the projection obtained on horizontal plane is known as top view. And when we observe from any side view and the projection of the object is obtained on profile plane, that is known as side. So we are starting orthographic projections in particular point. Okay. So as is shown in figure, this is a quadratic system. So we have four quadrants by using two horizontal plane and two vertical planes. From this arrow, when you looking the quadratic system or the planes, when the space which is above HP and in front of VP, that space is known as first quadrant. The space which is behind VP and above HP is second quadrant. The space which is below HP and behind VP, third quadrant. And the space which is below HP and in front of VP, that is known as fourth quadrant. Now for taking the projection of point, first of all, we have to select the location of the point. So there are 9 possibilities of the point which hold in this 4 quadrants. So let us see location of points. So first quadrant, when the point is in first quadrant means its address is like above HP and in front of VP. When the point is in second quadrant, as you know, above HP behind VP, third quadrant, below HP behind VP, fourth quadrant, below HP in front of VP. Now, these are the 4 quadrants where the point is in space. But when the point is exactly on horizontal plane, so there are 2 possibilities: either in front of VP or behind VP. So we have 2 horizontal planes. If the point is on HP and in front of VP, means our point is in horizontal plane in front of VP. Second, on HP and behind VP. Third one is on VP above HP and on VP below HP. So there are another 4 possibilities. And last, when the point is exactly on HP and on VP, then point is on the intersection of horizontal plane and vertical plane. That line is, denoted by XP or XY. Now let us see one by one the exact projection of the point when point is in different locations. Our first case, when point is above HP and in front of you. So in this object, you can see one horizontal plane, one vertical plane, both are intersects at perpendicular to each other, and our point A, which is located in first quadrant, means it is above HP and in front of VP. The distance from HP is denoted by small h, and the distance from vertical plane is denoted by V. Now, when you're looking from here and from here, there are two different locations for the view position of the observer. Okay. So when you observe from front, the projection of A obtained on vertical plane is denoted by A dash. This projection line is always perpendicular to vertical plane. And when you're looking from top, the projection of A obtained on horizontal plane, which is denoted by small a. So after taking the projections, when you rotate the horizontal plane clockwise, you will get the projections which are shown here. This is horizontal plane and vertical plane between XY. The position of VP is as it is, but the horizontal plane by moving clockwise 90 degree, it looks here like this. So A dash above XY H distance and small a below XY V distance. These are the projection on particular plane, but generally in drawing we will draw in the form of this drawing only XY, which represents horizontal plane as well as vertical plane. When you observe front view, XY is HP, for top view XY is VP. Question: draw the projection of point A if it is 20 mm above HP and 30 mm in front of VP. So for this particular questions, in our answer, the value of H is equal to 20 mm and value of V is equal to 30 mm. So similarly, for we can observe here, these are the animation of point A when you're looking from here, the projection of A on vertical plane A dash, and from top the projection of A on horizontal plane small a. Okay. Now for second quadrants, point A is in second quadrant, which is above HP and behind VP. So capital A is our object. So when you're looking from here, front view the projection of A on vertical plane A dash, and from top view the projection of A on horizontal plane small a. Now when you rotate the horizontal plane clockwise, the vertical plane and horizontal plane both are overlaps. So the front view and top view of orthographic projection is shown like this. Here XY above XY A dash at H distance and above XY top view small a at V distance. Generally it is denoted by this drawing. When question, draw the projection of point when 20 mm above HP and 40 mm behind VP. So our answer is here, in which the value of H 20 mm and value of V is equal to 40 mm. Now third quadrant. So point is below HP and behind VP. So look at in this figure where our point A is in third quadrant, means below HP and behind VP. So when you observe from here, the projection of A on vertical plane is denoted by A dash, and when you observe from top, the projection of A on small a is denoted by small a. Now to drawing for in single plane, we have to move always horizontal plane clockwise 90 degree. We do not move vertical plane. After revolving H 90 degree clockwise, our projection looks like this. XY, A dash is below XY, H distance, A dash, and small a top view above XY at V distance. Generally, it is represented like this. If your question is like this, draw a projection of point A if it is 15 mm below HP and 30 mm behind VP, and the value of small h 15 mm, the value of V is equal to 30 mm. Now for fourth quadrant, point is below HP and in front of VP. So in fourth quadrant, point is projected from front. The projection of A on vertical plane is A dash, and from top, the projection of A on horizontal plane is small. So by moving the horizontal plane clockwise, the projections look like this. Both the views, front and top view, comes below XY. And for particular questions, draw the projection of point A if it is 20 mm below HP and 50 mm in front of VP. So its projections on 2D, XY, below XY at H distance A dash, here H is equal to 25 mm, and in front of VP 50 mm, so here the value of V is equal to 50 mm. So in this lecture, we learn about the projection of point when point is located in first quadrant, second quadrant, third quadrant, and fourth quadrant. So the summary of this lecture is when any point is located in first quadrant, then its projections will be in such a way that the front view is always above XY line and top view is below XY line. When point is in second quadrant, its both the views comes above XY line. When point is in the third quadrant, its front view will below XY and its top view will above XY. And when point is in fourth quadrant, both the projections, front view and top view, means both the views are below XY. Okay. So thank you very much for watching this video.